Okay, in this part of lesson 1.6 on the law of sines, we're going to cover a couple things. We're going to look at finding the area of triangles and how to use the law of sines to solve the side-side angle setup case. Okay, so let's start by looking at finding the area of a triangle. Okay, I'm sure that in your previous lives you have learned I'm sure in your previous life, sorry about that, you've learned that the area of a triangle is equal to 1/2 the base times its height, right? Okay, well, that's all well and good, but what if you don't know the height? If you actually know a little bit of other information, you can still find the area of that triangle. So here's how we're going to do it. We're going to use trigonometry to help us find the area of that triangle. And here's how we do it. Okay, so same triangle right there. All I'm doing is labeling the sides and angles. And since I called this base B, I'm going to put angle B here at the top. And then just randomly, I'm going to label the other two sides, or the other two angles, A and C. Okay, now if that's true, if this is angle A, then this is side A, of course. If this is angle C, this is side C over here. And then we see this height. So say, for example, I knew base B, and I knew side C, and I knew angle A. Well, if I knew that information, essentially what I could do is kind of separate this right triangle that you guys see here, and I've redrawn it over here, right? So if I'm looking at angle A, this side would be the opposite side of A. This side would be the hypotenuse of A, and of course, this is C, and this is the height. So we can use our trigonometry here. We can say that the sine of angle A is equal to the opposite over the hypotenuse, or h over c. Okay, that's great. If the sine of A is equal to h over c, I can solve for the height by multiplying both sides by c. And if I multiply both sides by c, c over c is 1, so I get that the height is equal to c times the sine of A. Now we're going to take that information and plug it into our area formula. Area is 1/2 base times height, but now I know the height. I have an expression for it. It's c times the sine of A. So simplifying that gives us the formula that the area of a triangle is equal to 1/2 BC times sine A. Now, it's very, very true that not all triangles are going to be labeled ABC. So what's really important here? What's really going on in this triangle? Think about the information I told you that we knew in this case. We knew this side right here. We knew this side right here. And then we knew the angle that connected those two sides. So essentially what we have is a side angle side setup. And when we have that side angle side setup, we can say that the area of a triangle is equal to half the product of those two sides that we knew times the sine of the included angle. And so this is another representation of that formula. If I knew sides A and C and I knew angle B, I could say the area was 1/2 AC times the sine of B. If I knew sides A and B and angle C, I could say that the area is 1/2 AB times the sine of C. So again, the labels don't matter. What really matters is if you know two sides and the angle between them. Now, if you know two sides and you don't know the angle between them, you can actually use the law of sines to go back and find another angle so that you can use the law of sines to find that angle that's between the two sides, and then you can, again, apply this formula or this technique to find the area of the triangle. So let's go ahead and do that in an example. So example 1, let's find the area of triangle RST where angle R is equal to 115 degrees, side S is 4, and side T is 6. Now I purposefully labeled these as different letters instead of A, B, and C so you can see what we're looking for when we're trying to find the area. And again, don't forget to put that information over here on the left so that you can finish up your Cornell notes and use this as a study guide at the end of the unit or even in between. Okay, so of course the very first step that we're going to do is draw a picture. And because the angle that I gave you was 115 degrees, I'm going to try to draw this triangle so that it looks like it has a 115 degree angle. That's obtuse. So you can see I have an obtuse angle here, and then I just kind of complete the triangle. Now, I know that this angle is got to be R right here because that's my 115 degrees. It doesn't matter how you label the rest of the triangle. Just label one angle S and one angle T so that you can visualize, oh, side S is going to be over here and side T is going to be over here, and then you can plug in their lengths. Now, looking at this information that I have a side, I have another side, and I have the angle in between. That means that I can use that little formula to find the area. I know that the area is equal to 1/2 the product of those two sides times the sine of the included angle. So in this case, it's going to be side S times side C times the sine of R. Oops, I should put divided by 2 there. Sorry about that, because we want 1/2 of that. So plugging in those sides, that's 4 times 6 times the sine of 115, all divided by 2. So we set up my equation, and then it's really just a matter of using our calculator to help us get those values. So 4 times 6 times the sine of 115 is about 21.75. We divide that by 2, and we get about 10.87 square feet. Okay, so this was the first example. What I want you guys to do now is practice problem, is practice problem number 1, please. So go ahead and stop, and I actually am going to stop the recording and put the other examples in another section. Okay, so we're going to do problem 1 right now.